So yeah, what I teach through the Improv and Architecture School is kind of climate literacy. So what Ranald said, so around these big issues that impact what we build, how we build it, and how that works into the future. So there we go. So the kind of Improv and Architecture School that I started kind of as a kind of freelancer, kind of bit of consultancy and XYZ, is really about creating spaces to learn about this, because even in the architectural sector, this is something that's not been in the education system. So it's through no fault of anyone in particular that's not common knowledge, but it's something we do really have to cultivate quite quickly. So why kind of climate literacy as opposed to just sustainability? So this diagram here is the Earth system diagram that was really done from quite early by IFF, and this shows all the different things that interconnect when we talk about sustainability, so particularly in the built environment. So it's about far more than just energy, and it's about far more than just carbon, even though these are things we've gotten quite good at talking about quite recently. So just to really jump into things straight away, we are in what is a climate and ecological emergency. This isn't just slight change, this is changing the world as we know it. As we speak, there is a heat dome above Canada and America that's setting and breaking records. So this is what the world looks like in a snapshot past the last 2 years. So in the top left-hand side, we have temperatures 22 degrees above the average in Greenland. In the top right-hand side, we have 80% of the Bahamas underwater. And then the bottom right, we have mega fires and wildfire seasons that are exponentially worse than they ever have been. And this is all as a direct correlation to the kind of global heating as well. So there has been kind of evidence of climate change every single day since 2012. It's not something that's in every once in a while. It's not an anomaly. It's been a consistent background noise ever since. So it's been warned off for decades, but for the past 9 years now, it's been consistent every single day evidence. And there was this report from the Intergovernmental Panel on Climate Change. So this is the one that really jolted people 2 years ago into kind of action, that 12 years to save the world sort of rhetoric. So just to really explain what this report said, it said if we want to stay below 1.5 degrees, which is a kind of amount of heating above pre-industrial levels, carbon dioxide emissions have to hit zero by 2050. That's a non-negotiable. And achieving this means emissions have to be cut in half in a decade, in half again in another decade, and zero by 2050. But to do this, we need to really transform society. It's not just a slight tweak or a bolt on here and there, it's absolute transformation. And if this has to be done in a way that's equitable and it's just, industrialized countries must drive down their emissions far faster as well. So what does this mean for buildings? So the report was very clear about what that means for the construction industry and how buildings operate. So this means 1.5 degree pathways that keep us below that threshold. Building emissions have to be reduced by 80 to 90% by 2050. So that is huge. But on top of that, we are told that by last year, all new construction needs to be fossil-free and near zero energy. And then we need to have an increased rate of retrofit by at least 5% per year, year on year, to increase that. So this came from the Committee on Climate Change in the UK 2 years ago. So this was just a little bit of a scorecard that got put together to show how things were happening. So 2 years ago, 12 out of 33 sectors in the UK had no plan for long-term climate change. And we just had a report a few days ago that said that the gap between the adaptation necessary and what is happening is actually widening. So we're further behind than we were 2 years ago at this moment in time. And the Committee on Climate Change was also very clear. It said that we cannot meet this kind of net zero by 2050 that's legally binding target if we don't nearly completely eliminate greenhouse gas emissions from UK buildings. So the construction sector is incredibly important when it comes to responding to climate change. It has such a big impact. But in positive news as well, 2/3 of people when surveyed said that climate change is a global emergency. In the UK, it's actually 81%. So we've got this huge kind of increase of attention on the topic. And just to show up whereabouts we are in relation to that 1.5 degree threshold, we are currently about 1.2 degrees. So we've got a really slim bit to play with. But it is possible within the laws of chemistry and physics. So it is possible to get there. So you might wonder, like as everyone does, how big a difference does that half a degree between 1.5 and 2 degrees actually make? Because on paper, it doesn't sound like much, but in reality, it's a huge exponential increase. So if you look at extreme heat and how people are affected by that around the world, there's between 1.5 and 2 degrees, it's over 2.5 times worse of people being affected by severe heat at least once every 5 years. And as far as sea level rise goes, that's another 6 centimeters from 1.5 to 2 degrees. So if you can think of how many people in the world live in coastal areas, that has a huge impact upon life of all sorts as well. But we recently had the Scotland's Climate Assembly. So this is a really interesting thing that shows what the public think is necessary. So this was the first ever Citizens' Assembly in Scotland, and their question was, how should Scotland tackle climate change to tackle the climate emergency in an effective and fair way? So all these things that they're calling for they've been given all the information, they've been given consultancy to learn about this, and they've responded. So when you give the public the information, 97% of them say building quality must be improved. So this is just a wee bit of kind of market research that shows everybody wants this. 97% of people agree this is necessary. When it comes to passive house standards for new build, 97% of that assembly said it's necessary. 97% said planning should consider climate. As far as building non-residential, everything's increased. There's a huge demand for this. And then when it comes to retrofitting homes, 94% of the Assembly said that Scotland should try to establish itself as a world leader in this practice. So there's a huge appetite and kind of ambition in this part. So there was actually a kind of, one of the most amazing things that came out of this was the Assembly recommended the Scottish Government retrofit all existing homes by 2030. So that is a radical, huge ambitious thing. But if you in terms of creating work and stable green jobs, that could be revolutionary in itself. So that's just a little bit to show what's been coming out of that assembly there. And kind of from around climate change, there's been lots of different kind of narratives. There's ones like kind of David Attenborough's here, where it just says, just don't waste. As long as you don't waste things, things can be the same. But that actively overlooks the whole huge systemic changes that we really need to be seeing. We do have these kind of, we see it in cinema, we see it in documentaries. When things become very visual, they get a very strong response. So lots of people might have started to look at their plastic use after someone recommended you watch A Plastic Ocean or Blow Up Planet 2, because they have a bit of a personal solution or a quick fix. So they're quite good, stirring responses, but they again don't look at the full wicked problem. And then when you look at the world's CO2 emissions, they're very evenly unspread. So in the UK, we emit a huge amount over the global average of 4.6 tonnes. In the United States, on the left-hand side of this graph, it's huge again on top of that. But actually, the UK is quite vulnerable to climate change in comparison to its neighbours. But also, the countries that have been doing the least of the emitting, typically in the global south, are far more vulnerable than we are. We're insulated at the moment due to our geography. But as you can see, even today, with the heat dome above Canada and America, they are already feeling the effects of this quite drastically as well. But just to talk about greenwashing, just to tie that line in, make that link, this is when a company makes a product, a service, a building out to be more green than it actually is, usually without giving data to really explain this. So some examples might be claims about products or projects that aren't backed up. Other examples in the built environment are just throwing renewables at unsustainable design, because without addressing the fabric of a building, we're overlooking lots of the problems. Another is just throwing lots and lots of technology at unsustainable design. So if we're going from a start where our building regulations are not enough, to simply throw technology at buildings operating at the same performance isn't really going to fix the problem. But quite a recent one, particularly in architectural spaces, is just throwing greenery quite literally at buildings or on top of them. So in terms of this is the Bosco Verticale, which lots of people might think is the kind of typical what green architecture looks like. In its context, it works, but it's not a universal fit. And when you consider things like embodied carbon to put trees where they don't last their full lifespan, that comes questions as well. So now we're just going to do a really quick jump through the science, so just enough to understand some of these reports that are coming out, because they are quite jargon heavy. So just for starters, you can see in this graphic here that shows on the left-hand side, you've got the amount of carbon dioxide in the Earth's air, and in the colours, you can see how much hotter the planet's actually getting. So as we cross that kind of 350 parts per million threshold of safety, as scientists call it, we've had a big spike in temperature, and that's been really consistent. And actually 2020 tied for the hottest year on record along with 2016. So this is not the start of a new normal, this is the start of a rising baseline of how hot things can actually get. We then have Earth Overshoot Day, where since the 1970s, we've been using more resources than our Earth can actually regenerate. So at the moment, we use the equivalent of 1.6 Earths, and Earth Overshoot Day comes in about August or July. So on that day, we surpass what the planet can sustain on an annual basis. And just to link all that in, there's been lots of these kind of planetary tipping points that have been identified. So these are starting to go quite far sooner than they were predicted. So things like the Greenland ice sheet were not predicted to start melting till 2100. That's starting now. So we've got things happening faster than previously expected. So we're now going to just pull it back to the built environment, because the built environment has a huge impact, but at the same time, that impact could be an opportunity for doing climate good as well. So we'll just go for some of this. So the operational energy in the built environment is 28% of global carbon emissions. So it's absolutely huge. But on top of that, the embodied carbon of our built environment is another 11%. So that's where you get that 40% industry from. The construction industry accounts for around about 40% of all of the carbon we emit globally, which is absolutely huge. And there's never been a massive NGO campaign purely focused on the built environment. So we've had a bit of an oversight in that regard. So just as far as kind of embodied carbon, just because that might be a new term for some of us, this is the carbon dioxide you emit during the extraction of material, the manufacture, transport, and construction of the building material, taking into account its lifespan from cradle, so from the ground to grave, as in back into the ground, or cradle to cradle, to be continuously recycled as well. So just to really hammer that point home, everything on this graph that is not blue is something the built environment can have a positive impact on in reducing global greenhouse gas emissions and carbon as well. But just to talk about that, at different points in the building's lifespan, you get carbon being emitted. So everything from the building to maintenance to transport. Because at the moment, we currently say buildings that last 65 years have a long life, which in terms of responding to a climate emergency, we need to be building buildings that last, buildings that go beyond 100, 200 years at this point. Because kind of cement production is responsible for 8 to 9% of global carbon emissions. This is a huge contributing factor. That's a larger factor than several countries as well. And less than 3% of all of the things we talk about around climate change mention the energy efficiency of buildings. So there's this 28% figure, which is a huge thing we can actually reduce and start working on. But in the UK, a survey last year showed that 64% of the UK public had never heard of the concept of net zero before. So to lots of us, that's a common term, is very familiar. But when we're talking to the public and clients, this might not be something they've heard about. So this is a very useful thing to kind of just spot check and see how we're getting on at communicating that to the public. Because buildings can actually be up to kind of 250% worse than as designed. And this is a performance gap that we're starting to kind of really try and dig into and eliminate, because it's a huge waste of energy and resources as well. So because retrofit is one of the key things in responding to the climate emergency through the built environment. So 80% of the buildings we'll be using in 2050 are already standing up right now. And you can save 55 to 75% of the associated embodied carbon by retrofitting the building instead of wiping it out and starting afresh as well. And from the Scaling Up retrofit report, we were told that quite bluntly that if the UK wants to meet its Paris climate commitments, it must be retrofitting 1,000 homes every single day. So at the moment, it's not quite happening. But again, that's a huge potential for generating work, for generating stable green jobs, and for really driving down carbon emissions at the same time. So on top of that, 40% of any nation's healthcare costs actually come from its built environment. So this relates to things like asthma, fuel poverty, respiratory conditions, and other things as well. So healthy and sustainable buildings are actually a public health strategy. It's not just about climate, it's also about our health and well-being as well. So what can we actually do in that space? So we're actually very lucky. Lots of things already exist. And we already have things like CEDA's Sustainable Renovation Guide, which teaches us about improving homes for energy, health, and the environment. And then there's guidance from Historic Environment Scotland on working with traditional buildings as well. So we can use them straight out the box. They already exist, and it's fantastic. But we also have definitions of what net zero operational carbon actually is. How does it work? So this is about looking at low energy use, the measurement and verification of buildings, reducing construction impacts, low carbon energy, and then looking at that zero carbon balance. So this is something we can bring into all of the work that we do. So just some kind of quick things to remember: prioritize the adaptation, retrofit, and reuse of buildings over building new ones. And on top of that, everything we work on is actually an intervention into an existing ecosystem. Something was there before people built houses there. And statistics say that 90% of a building's environmental impact come from the very earliest design decisions. So where that building is and where windows go and orientation, etc. So always kind of strive for solutions over demolition. It's a really fantastic example by Collective Architecture of an inner-fit refurb of a 60s tower block. And it was a really incredible way of taking buildings that the residents actually loved quite dearly and making them as efficient as physically possible as well. And conservation is also incredibly important. So the traditional buildings that we have to work with, because lots of these traditional building skills are actually lower carbon than modern equivalents, and they're actually quite sustainable. Things like limecrete, lime plastering, clay plastering, etc. So this is an example of this about a conservation project. What is now the Centre for Conservation kind of training in Scotland. So that's the engine shed from Historic Environment Scotland as well. And if reuse is not an option, we need to design for circularity. So to keep materials and components in circulation, to reuse them. Because in Northwest Europe, only 1% of building materials or elements are reused following their first use. So they only actually used in one building, when realistically they should be able to go on and on and on. So the whole kind of circular economy is not just a buzzword, it's about keeping materials in flows and cycles. So that's kind of looking at an installed product in terms of the leases, maintaining it, and also with disassembly, reuse beyond just the installation as well. So a good example of this, the Butte Recycling Centre that was from Collective Architecture again, I was using many reclaimed and recycled materials as well. But on top of that, we need to be increasing the standards we're using. So building to code or the barest legal minimum is not really fit for an emergency. We need to go beyond what the kind of minimum bar is. So Passive House is a really good way to start doing this. So it's a really good, thorough method. So kind of fundamentals of Passive House are kind of optimal use of passive design strategies, an airtight building fabric with continuous insulation and thermal bridge-free construction, really high performance components, MVHR systems, and modeled as well and verified. So it's really going beyond the bare minimum. So typically in a UK context, passive houses achieve a 75% reduction in space heating requirements as opposed to standard. So that's a huge improvement on reducing costs of fuel, on building better buildings as well. So just an example you might be quite familiar with, this is Goldsmith Street by McAulay. It actually won the RIBA Stirling Prize. So for the first time, a social housing and passive house project won that prize, which really changed the game in that regard. So how it's been designed so fabric first to try and drive down fuel cost as much as possible and have a really lovely place to live as well. But this does bring in more complexity. So for building details and the amount of insulation that you can see here in red, it's been beefed up quite substantially as well. So what does that kind of mean on site for a passive house? So really, it means there's a far greater emphasis on build quality above all else and attention to detail. So how airtight buildings are, the kind of continuity of insulation, so wrapping that with no gaps, kind of the greater collaboration and more open communication channels, and also just all these different things, or how you sequence the build and thermal breaks in particular as well. So there are some really good examples in Scotland of this being done and very well. This is Closeburn Passive House from John Gilbert Architects, which is quite recent. But it's not just for new builds. This is a retrofit example in Manchester, which actually achieved the Passive House standard as well. It's a really good place to start to look. So in Scotland, passive house buildings are starting to get more common. We can now start to, this is through the Passive House Trust website, if you want to go and find any of these. And other examples are things like Lilac and Leeds from White Design. So this is a low impact co-housing scheme that was actually prefabricated using a straw bale panel system. So you can't really tell from here, but this is what that looks like. And lots of these systems are actually passive house certified, meaning that they actually can meet passive house standards straight away. But really importantly, they sequester a huge amount of carbon dioxide. Another example is a lovely house at Old Holloway by George McCurrick, who's from Archetype. And this is a self-built home. So this is proving you can build passive house standards with self-builders as well. And it's just a really lovely project where you can see these panels came in as different components and slotted together like Lego blocks, which made for a very quick and succinct build as well. But on the embodied carbon front, we do need to note that internal finishes are very important. So even how we paint, plaster, and build up from plasterboard. So alternatives to gypsum are things like clay, because clay can be lower impact and healthier, and it can also give you a bit of kind of moisture buffering and some thermal mass on top of as well. So it's very kind of adaptable to lots of systems. And just to put that in the context, some research was carried out which showed that a clay plastered wall gives you about 0.8 kilograms of carbon a square meter, but with gypsum it's 3.2. So that's a huge difference across a whole housing development as well. We then move into things like cross-laminated timbers becoming more normal. This is a kind of jumbo plywood that are assemblies of planks that are cross-laminated perpendicular layers and can form structural components that lock in a huge amount of carbon dioxide. And this brings us into examples in Scotland, like Plumber's Wood by Guy Architects, which uses a mass timber system called Brechdapple that actually sequestered 200 tons of CO2 in this one building, which is quite incredible, and even though that happened over a decade ago. And then we have more kind of recent and more kind of border specific as well. So Indie Nature are doing their kind of carbon negative building products using hemp and natural fibers. These are lots of different systems that combine to make their kind of proprietary ones. So these are really good places to start, that you can bring in these materials that are local to Scotland. And also we can learn from what we build. So we can do post-occupancy evaluation to learn from buildings, to improve upon things and to identify problems as well. So just from here, this is about looking at how the building works with people, energy and water, and also the internal environments. So this allows us to identify problems for this monitoring, and also means that the next thing that we build can be improved as well. So it's about learning and improving and making that feedback loop a bit stronger. So just to end kind of as succinctly as possible, everything that's not blue on this graph is something that your work in the construction sector can reduce the impact of and turn into an environmental positive. So working in construction is actually a fantastic opportunity to take climate action that can improve people's lives, improve public health as well.